This is Project 1.6, 1v1 Game Show Buttons. The 1v1 Game Show Button circuit is designed to detect the first button press and signal which button was pressed through illuminated LEDs and a buzzing sound, ensuring both players receive immediate confirmation of the outcome. The circuit employs a lockout mechanism to maintain fairness, disregarding subsequent button inputs after the first press. Including a reset button streamlines the transition between rounds, facilitating seamless gameplay. With its ability to deliver clear results in real time, the circuit can be used in game show and quiz applications. This circuit combines fundamental hardware components such as buttons, LEDs, and a buzzer, and uses Arduino programming for control. This project offers a practical application of basic circuit design. Initially prototyped on a breadboard for testing and refinement, the circuit is later transitioned to a perma-proto board for durability and long-term use. The breadboard prototype consists of 8 components which are shown on the parts table on screen. Each component connects to a digital pin on the Arduino. The yellow player button is connected to pin 2 and the blue player button to pin 3. The yellow and blue LEDs, which indicate which player pressed first, connect to pins 5 and 4 respectively. The buzzer, providing auditory feedback, connects to pin 8. Finally, connect the reset button to pin 6 and the power switch to pin 7. All of these components work together with the code to produce the desired result. The code is an important part of this project. The code uses an Arduino Nano to read input from 2 player buttons, control the 2 LEDs, and activate the buzzer. It includes functions to lock the button presses and reset the game. The code starts by defining a variable button lock module to track whether a button has been locked. It also defines the pins for the reset button, player buttons, LED, buzzer, and on switch. The variables lock state yellow, lock state blue, and reset state module are used to store the current states of the respective buttons. In the setup function, the code configures the required pins to behave as inputs using pin mode. The yellow and blue button pins, as well as the reset pins, are set as inputs. The initial states of the LEDs are set to off using digital write. The button lock module variable is initialized to 0, indicating that no button has been pressed. The lock yellow function locks the yellow button press. It first checks if the button lock module is 0, indicating that no button has been locked out yet. If this condition is true, it turns on the yellow LED and activates the buzzer with a 1000 Hz tone for 1 second using the tone function. This function then sets button lock module to 1, preventing further button presses. The lock blue function works similar to the lock yellow, but it locks a blue button press instead. In the loop function, the code continuously checks the state of the on switch using digital read. If the on switch is high, indicating that the game is powered on, it reads the states of the yellow and blue buttons. If the yellow button is pressed, which means the state is low, the lock yellow function is called. Similarly, if the blue button is pressed, state is low, the lock blue function is called. The function also checks the state of the reset button. The reset button is pressed, state is low. The reset block function is called to reset the game. Once the prototype functions correctly, we move on to the final build. For the final build, 7 additional components were required, as shown on the parts table on screen. The main component of this final build is a perma-proto board. Using a perma-proto for this project ensures a more durable and reliable circuit compared to a temporary breadboard setup. It provides secure and permanent connections, reducing the risk of loose wires and intermittent connections. The stability is crucial for long-term use, making it essential for turning prototypes into functional, lasting projects. Female headers on the perma-proto securely connect the Arduino Nano without direct soldering, allowing for an easy insertion, removal, and reuse, extending the Nano's lifespan. Risers are used between the holder and the perma-proto to create space for extensive wiring, allowing wires to pass underneath with ease. Large arcade buttons are used for their fun, tactile feel and durability, making them ideal for this game-type project. These buttons are handheld and are perfect for enhancing the interactive experience of the build. To display this perma-proto, I used a 3D printed holder. This holder provides structural support and gives the project a polished professional look, but without the time and material needed of a case. Overall, this project demonstrates a practical application of hardware and software. The circuit effectively detects which player presses their button first, providing immediate visual and audible feedback through LEDs and a buzzer. The use of a reset button ensures this system can be quickly and easily prepared for following rounds. By moving from a breadboard prototype to a permanent build, the project showcases the importance of creating durable and dependable electronics for long-term use. This is Project 1.6 1v1 Game Show Buttons, my ISP. Thank you for watching.